Hello and welcome back. It's Mrs. Saunders with another geometry lesson. Today we're talking about distances and midpoints. Now, midpoints, they're not so bad. People usually think they're pretty straightforward. The distance formula, I gotta be honest, not always a crowd favorite, but it's important. And so we're gonna take it step by step, and hopefully by the end, it's not so bad. So we're going to start with distances. Now we're going to start in one dimension and move to two dimensions. So in one dimension, basically, we're working with a number line. And let's say I want to find the distance between A and B. So I'm going to say AB equals, and when they're this close together, I can just count. I can count the spaces. 1, 2. Okay, the distance is 2. What about BC? I can count again. 3. Okay, ready for another one? FG. Okay, let's count. I know you're pretty good at counting. That's 5. But as these points get farther and farther and farther apart, you can't always see the number line. You can't always plot it on the number line. So we have another way to find the distance between 2 points on the number line, and that's to take one point and subtract the other. So if I take 8 and subtract 3, I also get 5. So let's try another one. Let's try AG. See, they're really far apart. Maybe I don't want to count all those spaces. So I'll just take 8 and subtract -9. Remember, when you subtract a negative, you're adding. So that equals 17. The distance between A and G is 17. Now, what happens if I had gone the other direction? What happens if I take -9 and subtract 8? I start with the number on the left. Well, then I get -17, and that's a problem because distance always has to be positive. You can't go a negative distance. So what we do is when we're working with distances, we just always make them positive. And in math, we use absolute value brackets to notate that. So the absolute value of -17 is 17. There's still 17 spaces apart. Remember, distance is always positive. So on a number line, we can sort of generalize this by saying the distance is x1 minus x2 or x2 minus x1. As long as they're in absolute value brackets, it doesn't matter which way you do it. Now we're going to move into two dimensions. We're going to look at distance on a coordinate plane. So we're going to find the distance between -6, 2 and 2, 5. It's this point here, -6, 2 and 2, 5 right there. Now, when the points are really close together, actually one thing we can do is just make a little triangle. And with that triangle, we can use Pythagorean theorem, which we're actually going to work with more later in the course, but let me just show you how it works. Pythagorean theorem says we take a side and square it, take the other side, square it, and that equals the hypotenuse squared. A squared plus B squared equals C squared. So in this case, it would be 8 squared plus 3 squared equals C squared. We're looking for this side here because that's the distance. That hypotenuse is the distance between our 2 points. So 8 squared is 64, 3 squared is 9. Add those together, we get 73 equals C squared. Okay, I'm not interested in C squared. I just want C. So I'm going to take the square root of both sides. And the square root of 73 is 8.544. If you want to round that to the nearest tenth, you get 8.5. However, just like when we were working with the number line, sometimes these points get really, really, really far apart. You can't always just make a triangle. So now we can use the distance formula, which is actually derived from the Pythagorean theorem, and it looks horrible. And this is when it's not a crowd favorite, because it looks long and it looks ugly, but really it's not so bad. So the distance formula, we've got the two x's, x2 minus x1, and the two y's, y2 minus y1. That's just like what we were working with on the number line. So what I usually do is I start with a blank slate, right? This stuff always stays the same. I always have the square root and then the difference of two numbers squared, the difference of two numbers squared. So let's just fill this in slowly, okay? So first thing we're going to do is take the x values, 2 minus -6. Well, when you subtract a negative, it's adding. So that looks like 2 plus 6. And then we'll take the y's, 5 and 2. So we've got 5 minus 2. And now we just do the math. Like 2 plus 6 is 8. 5 minus 2 is 3. Notice I haven't done these squares yet, so we'll do that next. So 8 squared is 64. 3 squared is 9. Look I'm getting the same answer. The square root of 73. Now, if you don't know off the top of your head what the square root of 73 is, grab a calculator. This is the TI-84. And in order to put the square root sign here, you see that? Look at right here. It's above the square sign is the little square root. It's hiding, so to get to it, you hit the second button and then the x squared button and put in 73. Square root of 73 is, there we go, once again, 8.5. So let's try another one. We don't have a coordinate plane that we can see right now, but we're going to find the distance between 5, 4 and -1, 2. So there's our distance formula. Start with our blank slate and then just plug in the numbers we need. So we've got -1 and 5, -1 minus 5, and then the y's, 2 minus 4. -1 minus 5 is -6, and 2 minus 4 is -2. Remember, distance is always positive, so actually this is how we're taking care of that negative number. Because if you square something, a negative times a negative makes it a positive. So that's how we make sure that all of our numbers are positive. Now you can't just square something and leave it. So that's why that square root sign is here, to undo that and get us back to an unsquared number. Anyway, back to this problem. So we've got -6 squared is 36. -2 squared is 4. 36 plus 4 is 40. We'll take the square root of that. And you get 6.3 if you round to the nearest tenth. Okay, so here's the next one. Pause the video for just a minute, please, and see if you can do this one on your own. How did you do? All right, let's see. Here's our distance formula. Here's what we're going to fill in. We'll take the x's, 3 and 8, 3 minus 8, and the y's, 7 and 2. Now we just plug and chug with the math. So 3 minus 8 is -5. 7 minus 2 is +5. -5 squared is 25. 5 squared is 25. So you add those together, square root of 50, plug it into the calculator, you get 7.1. That's the distance formula. Learn to love it. We're going to use it a lot. Now on to midpoints. So just like before, we started in the first just one dimension, and then we're going to move into 2 dimensions. Now the midpoint between 2 points is the average value of their coordinates. Meaning, if you've got these two coordinates here, we've got x1 and x2. To find the average, you just add them together and divide by 2. That's the general formula for midpoint. It's a little bit more friendly, isn't it, than the distance formula? So let's try this. We've got our 2 points. We've got -4 and we've got 2. So we'll add those together and divide by 2. -4 plus 2 is -2. -2 divided by 2 is -1. And yeah, it's smack in the middle, so that worked. That's 1 dimension. Now we're going to move into 2 dimensions and add some y values. It's actually not too bad though. Here's the middle point. We just took the 2 x values, divide by 2, add the 2 y values, divide by 2. Now you'll notice we're always dividing by 2, so that you just get to leave the same. Now we'll take the x's. Let's see, so we've got 2 plus -6. This time we're adding the coordinates. And 5 plus 2. So 2 plus -6 is -4. 5 plus 2 is 7. And so that ends up being -2, 3.5. And you can see that's smack in the middle. Let's try looking at this from a different direction. This one says, find the coordinates of the missing endpoint if M is the midpoint of NQ and N is the point 20 and M is the point 52. I know it sounds like alphabet soup, but let's see the information we have so far. We've got that N is at 20, so I'm going to plot that. We've got M is 52. So I've got my 2 points plotted. And notice Q is the end of a line, right? Q is the end of a line and M is the midpoint, which means Q has to be somewhat in this area, somewhere floating around in there, right? Okay, so how do we find Q? Let me ask you a question. If you start at N, how do you get from N to M? Well, you could just go up 2 and over 3, right? So that's the midpoint. If we do the same thing again, we'll find Q. We're going to go up 2, over 3, and bam, there's Q. So there you go, distance and midpoints. Thanks for being here.